Let's go to page 321 and start with number 2. You have A equal to I minus 2j plus 2k, and vector B equal to I plus j plus k. Okay, and this one, first you need to look for A dot B. So A dot B. So when you multiply the A dot B, you just go and multiply the coefficient. So 1 times 1 give you 1. Negative 2 times 1, this will give you negative 2. 2 times 1 give you plus 2. Okay, so you got A dot B equal to 1. Okay. Next, you have to look for the cosine theta. Okay, so you start with the basic equation, the A dot B equal to A B cosine theta. So this is a very important equation. Make sure you always start with this equation. And since you're looking for cosine theta, you need to move this over. So cosine theta. So it depends on what you're looking for. You have to kind of manipulate your equation. So cosine theta equal to 8 dot B over A B. Okay, so cosine theta equal to, now A dot B, we already got it from here. Okay, so now to find the magnitude or the length of A, you just look at A and you just take again, use your Pythagorean theorem. So 1 squared is 1, negative 2 squared is 4, 2 squared is 4. Okay, so that's magnitude of A. Now to do the B, you do the same thing. So coefficient of 1 squared, you get 1. Over here, 1 squared, you get 1. 1 squared, you get 1. Okay, so cosine theta is equal to 1 over square root of 9 and square root of 3. You simplify. So cosine theta is equal to 1 over 3 square root of 3. And if you're going to simplify, you multiply by square root of 3, square root of 3. So cosine of theta is equal to square root of 3 over 9. Okay. So again, it's not asking for angle, it's asking for cosine of the angle. So keep it as cosine theta. If it asks for the angle, then you have to figure out the degrees. Okay. Okay, let's go to number 4. Okay, you have A equal to I minus j minus k, and you have vector B equal to 4I minus 8j plus k. Okay, so same thing. So A dot B. So when you have a dot product, you just multiply their coefficient. So 1 times 4 give you 4. Negative 1 times negative 8 give you plus 8. Negative 1 times 1 give you minus 1. So watch for the positive negative. So A dot B equal to 11. Okay, so we're going to do the same thing as this one over here. So so you're looking for the cosine theta. So start with your A dot B equal to A B cosine theta. Again, that's your equation. So you always start with this one, then you can start move things around. You're looking for cosine theta, so you have to move over. So cosine theta equal to A dot B over A B. So cosine theta equal to, now A dot B, we already found A dot B from here. So it's equal to 11. Now magnitude of A, so that's, you have to use Pythagorean theorem. So use your A. So 1 squared is 1. Negative 1 squared is still 1. Negative 1 squared is 1. Okay, so that's magnitude of A. Now to find the length of B, again, you go to coefficient of the B over here. So 4 squared is 16. Negative 8 squared is 64. And 1 squared is 1. So you get cosine theta equal to 11 over square root of 3, square root of 81. So you get cosine theta equal to 11 over 9 square root of 3. And to simplify, to get rid of the square root on the bottom, multiply by square root of 3. So cosine theta equal to 11 square root of 3 over 27. Okay, let's go to number 6. number 6, you have A equal to 2I minus J plus 3K. You got B equal to I plus J minus K. Okay, so again, you're looking for A dot B. So when you have a dot product, you just multiply their coefficient. So 2 times 1 equal to 2. Negative 1 times 1 give you negative 1. 3 times negative 1 give you minus 3. Okay, so A dot B is equal to negative 2. Okay. Next, we're looking for cosine theta. So you can start with your equation. A dot B equal to A, B, cosine theta. And you're looking for cosine theta. So cosine theta equal to A dot B over A, B. So A dot B, we already did that over here. So it's negative 2. And magnitude of A, use your Pythagorean theorem to find the length. So look at A. So 2 squared is 4. Negative 1 squared is 1. 3 squared is 9. Okay, so that's length of A. Now to do the B, you go to the B. So 1 squared is 1. 1 squared is 1. Negative 1 squared is 1. Okay, so again, that is the magnitude of A, or the length of B. So length of B, you just go to coefficient. Okay, so you get cosine theta equal to negative 2 over square root of 14 and square root of 3. So cosine theta equal to negative 2 over square root of 42. Now the book answer is kind of a little bit inconsistent because this one they kind of just leave it like that. They did not simplify, so we just follow the book. Okay. So either way is acceptable. Okay, let's go to number 8. Okay, so again you have A equal to AI plus 4J minus K. Vector B equal to 2I minus 3J plus K. So this one you have to do two things. Okay? You have to do the vector, you have to do the scalar projection, which is the length, and also need to get a vector projection. So just for visualization, this one you're looking for the projection of B on A. Okay? So draw your vector, so B, and you, again, projection is like the shadow. So make the A kind of long. So you're looking for the shadow. So B on A means you're looking for the shadow that B casts on the A. So you're looking for this part right over here. Okay? So here's your theta. Now this part is equal to the length of B times cosine theta. Okay, that's what this part equal to. Okay, so you can, so the length of B, that's the hypotenuse times cosine theta will give you the horizontal, the shadow that it casts on here. So that's what you're looking for. So you can start with your equation. So start with your equation. A dot B equal to A, B, cosine theta. Again, you always start with this equation, and then you can go and move things around to get what you're looking for. So the scalar projection is this. So that's what you're looking for. That means you have to get this over. Okay. So it's equal to A dot B over A. So again, this is what you're looking for. So from your equation, you just move this over, and that's what you need to do. That's what you need to calculate. Okay, so let's go and do that. So A dot B, again, you come over here. Okay, so 8 times 2 is 16. And you go over here. 4 times negative 3 give you minus 12. And you got negative 1 times 1 give you minus 1. Okay, and you have to over the length of A. So you come over here. So A squared is 64. 4 squared is 16. And negative 1 squared is 1. Okay, so B cosine theta, or the scalar projection, is equal to, so this will equal to 3, and this will give you square root of 81. So this will give you 3/9. So this is just scalar projection. Scalar projection is the length of the shadow. Okay, so this is the length. So again, so the shadow, the length of the shadow is 1/3. Okay, so that's your scalar projection. So now we have to do the vector projection. So you want to, not only the length, you have to look for the direction. So now notice the shadow. So you'll be looking for the vector projection, means you also look for the direction. So you're looking for this vector over here. So notice this vector is the same direction as A. So you start with, so the vector in the direction of A, you start with that direction. So first get the direction correct. Okay. So again, this vector right over here, so that's the part you're looking for right over here. So that vector has a direction of A. So you get the direction first. Okay. So so you get the direction. So now you have to get the correct length. This has a length of 1/3. Okay. So you have to get the correct length. So first you have to divide by its length to get into length of 1. So now you want to get the unit vector. So divide. So the vector of this is, again, that's the A, right? So it'd be 64, and this would be 16, this would be 1. Okay, so again, so first you get your direction, divide by its length to get the length of 1. Then you have to multiply by the length that you want, which is 1/3. Okay, so again, you start with the direction, you divide by its length to get the length of 1. And then from length of 1, you can get any length that you want. Okay. And this one is equal to 9. So the vector projection in the direction of A will equal to these. Right? So if you work it out, you're going to get 8/27I plus 4/27j minus 1/27k. Okay, let's go to number 10. So you got A equal to 2I plus j plus k. And you have B equal to 2I minus 2j minus k. So for number 10, you're going to project the A on B. So again, you have to pay attention which one is casting the shadow. So you're doing the A on B. So you're going to do the vector A casting the shadow on B. Okay, so you're looking for this part right over here. That's what you're looking for. Okay. Okay, so again, this part over here, this length over here, that is the length of A times cosine theta. Okay, so that is this part over here. So that's what you're looking for. So you can start with your equation. A dot B equal to AB cosine theta. Okay, then after that you can move things around to get what you're looking for. So you're looking for A cosine theta because you're looking for the shadow of A casting on B. Okay, so A cosine theta means you have to get rid of the B. So it'd be A dot B over vector B. Okay. So again, the vector A casting shadow on B. So this is casting shadow on B. Okay. So whatever is on the bottom is going to be on the bottom. Okay. So now it's just a matter of working out the math. So A dot B. So you multiply over here. So 2 times 2 is 4. I say use your finger. Okay. And then over here 1 times negative 2. 1 times negative 2 is minus 2. And over here 1 times negative 1 is 1. Yeah, minus 1. Okay. And the length of B, you go over here. Okay. So 2 squared is 4. Negative 2 squared is 4. Negative 1 squared is 1. Okay. So that's the length of B. So this will give you 1, and this will equal to 3. Okay. So that is the, again, this is the length of the shadow. Okay. Now, so this is a scalar projection. Now you're looking for the vector projection. Okay. So now you're looking not only the length, but you also need a direction for that. So the vector of A, the vector projection on B will equal to. So again, first let's get the direction. So since this is same direction as B, right? Since this is same direction as B, so it must have the same coefficient. So we start with that. Okay. So that's the direction. So now we have the direction correct. Now we have to get our length correct. Now to get the correct length, first we have to divide by its length to get the length of 1. So 2 squared is 4, negative 2 squared is 4, and negative 1 squared is 1. Okay? So divide by its length. So now we have the direction and we have length of 1. And then we have to multiply by the length that we want, which is 1/3. Okay? So this one has length of 1/3. So we have to multiply by 1/3 to get a length of 1/3. Okay, so go and work it out. So this will equal to 3. So the vector projection would be 2 over 9i minus 2 over 9j minus 1 over 9k. Okay, let's go to number 12. Okay, number 12, you try to determine if the vectors are perpendicular or parallel or near. Okay. Okay, so number 12, you got vector A equal to 2i minus 3j plus 4k. B equal to negative I plus 3 over 2j minus 2k. Now you can do the dot product right away, but that's a quick way to do this. Is if you notice the coefficient, if you multiply the b by 2, you're going to get negative 2i plus 3j, and this will give you minus 4k. So you can see that they are directly opposite. Okay, so they're opposite. So what it's saying is that vector B is half the length of A, and they're going opposite direction. Okay, so B is parallel to A. Okay, but because these are opposite, so they are opposite direction. Now, just additional note that that A equal to 2 times the length of B. So these are just additional information. Now, if you don't see that, you can also do the dot product test. Okay, so A dot B. So A dot B, you go and multiply. So this times that give you minus 2. This times that will give you minus 9 over 2. And this times that will give you minus 8. Okay, double check. Okay. And let's see. So A dot B, if you work it out, this is what you get. Okay, so 2 negative minus 9 over 2 minus 8 equal 2 negative minus so this will give you negative 29 over 2. Okay, then after that, what you need to do is to find the angle, notice cosine theta equal to A dot B over A B, right? So you can find out the angle between them. And then A is going to be 4 plus 9 plus 16. And this one's going to be 1 plus 9 over 4 plus 4. So if you do a little bit of math, this will equal to 29, and this will be square root of 29 over 4. Okay, so cosine theta equal to negative 29 over 2. Again, if you simplify this, you're going to get 29 over 2. So cosine theta equal to negative 1. So theta equal to 180 degrees, right? So it can kind of match that, right? Again, they are opposite direction, okay? So again, if you do that, you have to kind of go through this whole thing, okay? So a lot of time we kind of have to look at equations. Sometimes we can get it quicker by just looking at that, okay? But if you don't catch that, you have to go through this whole thing to find out the degree. And you can see that when theta is 180 degrees, okay, that means they're opposite direction. Okay, let's go to number 14. You have A equal to 3I minus 2J, okay, plus 7K. B equal to I minus 2J minus K. Okay, so let's go and do a quick testing. So A dot B equal to, so 3 times 1 is 3. Negative 2 times negative 2 is plus 4. 7 times negative 1 is minus 7. So A dot B equal to 0. Okay, so when the top part equal to 0 means they are perpendicular. Okay, so that means A is perpendicular to B. And the reason is because, remember the equation? Because the equation, the A dot B equal to A B cosine theta. Okay? So when A dot B equal to 0, you get this situation. And you divide by AB, you still get 0 equal to cosine theta. And therefore theta equal to 90 degrees. Okay, 90 degrees means perpendicular, right? Okay. Okay, let's go to 16. So 16, if you were to draw a cube, so you have a cube. Okay, so you're looking for the angle between the diagonal of, so you're looking for the angle between diagonal and a face. Okay, so I'm just drawing this one. So you're looking for this angle right over here. So the diagonal of cube, okay, I'm going to call it A. This is equal to I plus J plus K. So basically it means you equal 1, 1, 1, right? So that's 1, 1, 1, right? So again, you go, so 1j, 1i, 1j, 1k. So that's the diagonal of the cube. And I'm going to call it A. Now the diagonal of a face, I'm going to call it B. Okay, now it depends on which face that you do. Okay, so like this face would be IJ, right? Okay, if you take this face over here, be I'm sorry, this is a IK. If you take this one, it would be IJ. Okay, and if you take this face, would be JK. So there are three choices. Okay, again, there are three choices. You got this one. You can use this face, this face, this face. Okay, but it doesn't matter which one you choose. Okay, so you got A dot B. Again, start with your equation. A dot B equal to A B cosine theta. Okay, and you're looking for cosine. You're looking for the angle between them. So you have to move things around. So cosine theta equal to A dot B over length of A, length of B. So cosine theta equal to A dot B. So again, doesn't matter which one you choose, you're gonna get 1 plus 1. Okay, the other one's gonna be 0. Okay, doesn't matter which one you choose. Okay, so you're gonna get 1 plus 1. The third one is gonna equal to 0. And the length of A would be square root of 1 plus 1 plus 1. And the length of B, again, doesn't matter which one you choose, you're gonna get 1 plus 1. Okay, so again, doesn't matter which you choose for B. You're going to end up with the same result. And cosine theta, so you can work it out. So you got 2 over square root of 3, square root of 2. Okay. Now, this part over here, 2 over square root of 2, that's equal to square root of 2. So if you simplify that, this part, you're going to get square root of 2 over square root of 3. Now, if you use your calculator, so theta will equal to 35.26 degrees. And if you run it off, to the nearest degree, so theta equal to 35 degrees. Okay, so that would be the angle between the diagonal of a cube and the diagonal of the face.